so now we can get to the real juicy stuff, and that's going to be these two-body problems. Now for these, my tips are the following. Be consistent in applying direction. Draw and understand the free body diagram for each object, and then know that the magnitude of the connecting force, so the connecting force is the thing that keeps these two things together such that they're going to move in the same way. So the magnitude of that connecting force is going to be equal but opposite in direction. So that's Newton's third law there. Now for this direction thing, right, the direction chosen as positive or negative must be consistent for the system. So let's say, for example, we've got these puppies that we are going to suspend from this crate here. If the puppies are going to move down, and we call that the positive direction, then for the crate, if the puppies move down, the crate has to move rightwards. So because we chose down as the positive direction for the puppies, we have to choose right as the positive direction for the crate so that there can be consistency, right? So if one object moves in the positive direction, the other one must also move in the positive direction at that same time, right? Here's another example. If the green kettlebell is going to move down, and we call that the positive direction, then if green goes down, blue goes up. So for the sake of consistency, the positive direction for the blue kettlebell is actually going to be upwards, and that's going to help us to then put in the correct signs for our vectors. Then remember, the magnitude of the connecting force is equal but in opposite directions. So here, this tension force that is going in the positive direction, right, will be the same in magnitude as this tension force that's going in the negative direction. But again, they'll be, as we said, same in magnitude, right? So here you can see it's going positive for the box and negative for the puppies, but the size is going to be the same, right? And then if, for example, this guy's pushing a crate, the force of the crate on this box, right, so I'm going to call it the F of A on B, will have the same magnitude as the force of the other crate on that box, which I'm going to call F of B on A. So they'll have the same magnitude, but they'll be opposite in direction. Okay, so a man pushes two crates, a 20 kilogram and a 25 kilogram crate with a force of 100 newtons. The frictional force on A is 40 newtons and the frictional force on B is 50 newtons. Find the force that A exerts on B. Okay, so very important, as I said, is we need to understand the free body diagram. So for A, we're going to have normal going up, we're going to have Fg going down, we've got a frictional force this way of 40, we've got a force that B exerts on A going to the left as well, and we've got our applied force of 100 newtons going towards the right. Okay. Now, normal and Fg we don't really care about here because we're not trying to use the normal to find friction. We were told what friction is, so we're not going to calculate those. So if we go and write our object A, F net equals ma, right? And here for consistency, the right is going to be positive, the left is going to be negative, right? We're going to get the Fa to the right minus the friction to the left minus the force of B on A to the left, which is equal to ma, and we can sub in. We can say 100 minus the 40 minus Fb on A, which we don't know yet, that's actually what we're trying to find, is equal to ma, and that's going to be 20a. Okay, so the force and the acceleration are the missing bits, right? Let's see what we can get for B, right? Now for B, we are again going to have a normal up, this down. We've got friction going to the left, right, and to the right we've got the F of A on B. Now note, we're not going to say that the man's applied force is acting on B because the man's not pushing on B, he's pushing on A, right? So that F of A on B is going to, in a way, include the force of the man pushing on A, right? So here for our F net, so here for B, the F net, we're interested in the horizontal bits, right? And again, because of consistency, rightwards has to be positive. So that's going to be Fa on B minus the friction which is equal to the MA, right? So now the FA on B we still don't know. Okay, and the friction we do know. We were told it was 50. Okay, so minus 50 is equal to 25A. Okay, and now life is good. Why is life good? Because we've got two equations with something that's got the same magnitude. FB on A and FA on B have the same magnitude, and we've got the acceleration. So we can go and solve simultaneously. Okay, so what I'm going to do is I'm going to make the acceleration the subject of the formula here. So 100 minus 40 is going to be 60. So 60 minus the FB on A is going to be equal to 20A, right? And then if we divide both sides by 20, 60 divided by 20 is going to be 3. So that's going to be 3 minus 1 over 20 of the FB on A, which is equal to this A here. Okay, and then wherever I see A on this side, I can go substitute that in. Okay, now I have not used my space well, so I'm going to get rid of this, RIP, so that I can go continue my equation there. So then what I'm going to do is we've got the FA on B, minus 50 equals 25A, right? So as we said, wherever we see A, this acceleration, we're going to go sub in. So minus 50 is equal to 25 times the 3 minus the 1 over 20 FB on A. Now, these two things are the same magnitude, right? So I'm going to stop writing FA on B and FB on A. I'm just going to put F there. And we know that what we're going to solve for is the FA on B, FB on A. Same magnitude, same size, same answer. Okay, so F minus 50, so let's keep the F minus 50 is equal to, okay, now 25 times 3 is 75, and 25 times negative 1 over 20 is going to be negative 25 over 20 times FB, right? And now that negative 25 over 20 I'm going to take to the other side. So negative 25 divided by 20 is going to be negative 1.25. So on this side I've got 1F, and I'm going to add the 1.25F, so I get 2.25F, and then the 75 plus the 50 is going to give me 125, and now I can get that F, the magnitude of the force, so 125 divided by 2.25 is going to give us 55,56. So the force here is equal to 55,56. So A exerts a force of 55,56 on B in the rightwards direction. B exerts a force of 55,56 newtons on A in the leftwards direction. Okay, so the very important thing for these two-body problems is that first you use the direction consistently for both objects. You understand that the connecting force, so here it was A pressing on B, pressing on A, and other times it's going to be tension, usually tension, right? You understand that the connecting force has the same magnitude but opposite directions for both objects. You're able to write the F net equals MA equations for both of the objects, and you can do that because you understand the free body diagram for both of the objects. And then once you can write the F net equals MA and substitute into the F net equals MA with what you have and what you don't, then you can simply solve simultaneously, usually for tension and acceleration. So that's where we're going to give it a stop today. Thank you so much for joining me for this workshop session. Good luck with your exams and your preparation. Remember, practice makes perfect. I'll see you next time.